Okay, let's have our battle queue get filled up with actual battle queue data. For that we're going to need a battle queue class, and we have to be able to find it. So we're going to go into our script, and we're going to make sure that everyone can find the active battle queue whenever they need it. We're going to put this in awake rather than start, because awake happens first. We want all of this stuff to be defined before we actually start up. I actually went and started back the combatant. We start this up in awake as well. That's because battle queue here, we're going to do something in the middle of start. So when start boots up, you don't want to have these still filling in. So it's good to do this in awake rather than in start, because awake happens first. Since we know that all the combatants have already checked in, we can just walk through them. QVisual, QV, equals QVisual, instantiate, combatant.activeCombatants.a.QVisual, QV.transform.setParent transform, and we don't want to keep our world position. There we go. That's pretty easy. Now all we have to do is drop that class onto our battle queue and hit play. Boom. But that's definitely not the right order. In fact, that's pretty much the exact opposite order. We want these characters to fill in according to their speed. And more than that, we need them to repeat. We need them to fill out the whole queue. We don't want just 4 of them. So to deal with that, we are going to have to make a system where we can determine which characters go when. Now there's a lot of ways of doing this, and I'm going to teach you a simple sim method. So to have that happen, we need to create a new class here in combatant. Or not a new class, sorry, a new function. Public float next turn float min time. So when is our next turn, and if it's before the min time, we just keep projecting forward. That means that we have to know how long it takes to have a turn. We do know how many actions per minute we get, but we don't know how many actions we need. How many action units does it take before you have a turn? Well, let's go ahead and set up a public float action units equals -50. And when your action units hit 0, your turn is ready. See? So if you spend 100 action units on your turn, then you'll go down to -100. If you spend 30 action units on your turn, you'll go down to -30. And it'll just count up, and when it hits 0, it'll reset. Now, you could obviously do it the other way, where you count downwards or something, but it doesn't really matter. So here in next turn, we're going to say float next turn equals negative action units divided by action units per minute. So if we were at -50 and we have 100 action units per minute, we will be returning 0.5. That's pretty simple, right? While next turn is less than min time. But if our next turn is before the minimum time we're currently allowed, we need to keep going. Now, how far down do we keep going? Our action units are set to -50 here, but what is the default? If we want to assume that someone is going to take a turn, do we have some kind of average turn length that we use in order to have that happen? And the answer is sure. We can make it whatever we would like. In this case, there might as well just be defined as a static int, which we can deal with later, change it up however we would like. Default action units per turn equals 50. So we would say next turn equals, and then plus equals rather, negative default, just default action units. Default action units per turn divided by action units per minute. So by adding to our next turn, we keep going. So if we're asking for the time after 0.7, then we would say, okay, well, -50 to 0 takes 0.5, and then -50 to 0 takes another 0.5, so our next turn would be at 1. I hope that makes sense. We should go ahead and make sure that there's no error here. If action units per minute is less than or equal to 0, debug.log name plus has no speed at all. Paralyzed. And then we will return something ridiculous like -1. Alright, that was pretty straightforward. Now all we have to do is make the battle queue walk through all of the combatants and ask them when their next turn is. So let's go back over to the battle queue and do that. Well, we should break this up into its own function. So, display. I think that display is actually a reserved keyword. Queue. Float time equals 0. And what we need to do is march ourselves forward through all of the combatants until we have hit a certain number of slots. So let's go ahead and set that up here. Public int display slots equals 10. Int displayed equals 0. So here we'll say displayed ++, and here we will say while displayed is less than active, alright, so what we're trying to do now is we're going to break out of this thing where we just set this up like so. What we actually need to do is find which of the many characters is the next one to go. So to do that, we are going to have int next. I guess we don't need it to be int, do we? We'll just make it a combatant. Combatant next to act. And we also need set that equal to null. And we also need a float next time equals time. Here, we simply ask each combatant what their next time is going to be. Combatant.activeCombatants a.next turn, and our min time is time. So we're saying, how long is it until your turn? And this might be in the future. We might be saying, well, after 15 minutes, when is your next turn? Very straightforward. And then we say, okay, well, if my next time equals -1, or less than 0, continue. There's an error. So if you're not going to get to go, just skip it. If my next time is less than next time, or next to act equals null, next time equals my next time, and next to act equals combatant.activeCombatants a. Like that there. So, what we're saying is that while we don't have enough things queued up, we're going to look for the next person, and we're going to ask everyone if they're the next person. And if they are the next person, we're going to display them. But we do want to make sure that there is a next to act. If there is no next to act, else debug.error warning, no active combatants, please program an end state break. Okay, so this is a fairly straightforward little query, but it's not one that most people have probably gotten used to writing yet, so I'm going to go ahead and we'll walk through it. Time starts at 0, which is 0 seconds into the future, and we have 0 displayed objects. While we have... Why is this less than active? Wow, that was a... Good thing I went back through it. That made no sense. While displayed is less than display slots, we're going to go ahead and find the next, most recent combatant, which we do by walking through all of the combatants and telling them, what is your next turn? Asking them, what is your next turn in the future? And they say, okay, well, my next turn is such and such, and we say, well, is that the best one we've got? Yeah? No? Good? If it is the best one we've got, then we have to set up so that our next time is our... yeah, like so. There. Good thing I went back through it. There were a couple of pieces I forgot because it's really late. So we go through and we say, when is your next action? Is it never? If it's not never, is it before the next guy we've already had? Is it the more recent? Is it more sooner? If it is more sooner, how sooner? Remember that so that we can compare it later on. And, of course, you are currently our next person to act. Go to the next person and ask them if they act sooner than the guy we just asked. So down here we say, well, if we do have someone who's acting, then we'll get their cue, we'll add it to our list, and we will make sure that our time is their turn time. That way, when we ask the next group of people, it's not going to trigger this person again. Or if it does, it's because they're super, super fast. And, of course, display ++ so we can stop displaying. Now, the other thing we need to do is we need to make sure we're not accidentally having a problem here. We're passing along a min time, and if we exactly match that min time, we need to not trigger, because that min time is set by our exact parameter. So if we say 0.346, then if someone comes by and says the minimum time is 0.346, that's probably our turn, and we don't want to say, well, yeah, that's me again. That would be very silly. So instead, we need to make sure that, yep, less than min time. There we go. Good thing we checked. And we are now going to try it out, see how that works. There's 5 of them. So our Frog Samurai is fastest with 100, and then our Yellow Magician is with, I think, 80, and then the Axe Lady has 75, and you can see that that repeats. These have 60, but there's only one of them right now. If there were actually 9, it would be like, shoom! So for now, that's going to repeat, but you can see that the Frog Samurai is actually fast enough that she loops, she passes the enemy here, and the enemy slips back a notch. And that's the sort of thing that's going to be interesting. So if we were going to create a lot of bird skeletons like this, and then we could alter them slightly, 62, 55, 68, 51, and now we hit play. You can see that there are a whole bunch of them in a row, and that's because they're all slower than any of our combatants, but we don't fill up as high as we might want to. So let's go back in, and we'll just improve that length. We'll change it from 10 to 16. And this is something we can do as much as we would like later. Oh, that didn't take. Oh, of course it didn't take, because that's not a global value. That's something we actually set right here. So if we have a lot of different battle queues, we can set them individually, which we will, actually. We're going to have at least 2 battle queues. So here you can see what just happened. We wrapped in front of most of them, but one of them was fast enough that we didn't actually manage to loop them. And that means that we've got this broken approach here. That's the sort of thing we were looking to get, and it looks like it worked out just fine. The only thing left for us to do is to make this battle queue have way less padding. That's way too much padding. How about 4? That's still too much padding. How about 0? That's better. We could probably get even more out of it, but that's fine. So we have now got a battle queue which displays our characters, and displays them in the correct order. We can recalculate that pretty easily. Now, if we were doing a mobile game, recalculating these things might be a little bit iffy, because there would be a lot of things, 16 of them, that get deleted and recreated. But if it's not a mobile game, that probably doesn't matter. 16 things being deleted and recreated every few seconds is not a big deal. But just keep in mind that if you were going to be creating a mobile game, you might want to approach this in a way which preserves these objects. Because right now, our approach is going to be to blow them all away and try again. And that works fine if we wanted to. So, for example, if we were going to change one of these action units, so for example, if our first turn got taken, their action units would change, and everyone else's action units would increase by the amount of time that passed, and then we would recalculate the whole list. The fun thing is that the ones in the front aren't going to change, not unless you take an action so short that you cut back in. But like these guys aren't going to rearrange within their order, and these people aren't going to rearrange. Only the active characters are going to be slotted back in a way that's different than you might expect. I'm not 100% sure that was super coherent, because it involves simulating a time in an arbitrarily far down the line. If you have a hard time understanding what I tried to show you in this episode, please let me know down below. It's more important than usual this time because I'm not at all clear about whether I was clear.